For more than a century, upstream natural gas extraction has served as the industrial cornerstone of Alberta's provincial economy. In the 2005 to 2006 fiscal year, the provincial government collected $8.4 billion in natural gas and byproduct royalties. This chart tracks that royalty revenue over a 15-year period. By the 2019 to 2020 fiscal year, those provincial collections had dropped to just $371 million. Look at the production volumes over that exact same timeline. Output only fell from 14.1 billion cubic feet per day to 11.1. The province was still extracting massive quantities of gas, but the economic return had essentially vanished. This economic disparity stems directly from an infrastructure bottleneck. Producers have relied entirely on a single, increasingly saturated export market, without the pipeline capacity required to reach alternative buyers. This map illustrates the resulting geographic trap. Alberta's reserves are landlocked. At the same time, massive expansion in the United States Gulf Coast production zones has squeezed Canadian supply out of its traditional southern distribution routes. Without diverse market access, Alberta producers are forced to sell a premium natural gas product at a severe and persistent discount relative to global benchmarks. A simple extract and export model cannot survive these market conditions. The province has to engineer an entirely new natural gas economy from the ground up. The 2020 Natural Gas Vision and Strategy outlines the mechanics of this industrial recovery. The strategy positions the natural gas molecule as a foundational chemical feedstock for domestic manufacturing and value-add processing. This diagram maps the architecture of that integration. A single node of raw natural gas is split into 5 distinct industrial pathways, capturing the economic value before the resource ever leaves the province. This framework carries a dual mandate: maximize the gross domestic product extracted from the resource while strictly complying with the greenhouse gas reduction targets established by the Paris Accord. To stabilize the sector, government and industry must simultaneously engineer these 5 interdependent pillars. The foundation of this system begins within Alberta's borders, utilizing the extensive midstream infrastructure already in place. The first pillar requires the expansion of intra-Alberta demand. By increasing domestic consumption, the system creates a stable, predictable baseload for upstream producers. The primary mechanism driving this demand is the ongoing conversion of the province's legacy power generation facilities from coal to natural gas. Replacing coal with natural gas directly reduces the greenhouse gas emissions generated by the provincial electrical grid. This chart shows the scale of that transition. Natural gas consumption for electricity generation is forecasted to climb from 1.2 billion cubic feet per day to 1.9 billion by 2029. The electrical grid is only one part of the domestic equation. Natural gas is also the primary thermal input required for in situ bitumen extraction in the oil sands. As oil sands production increases over the next decade, the associated natural gas demand is projected to grow from 1.9 to 2.7 billion cubic feet per day. Securing this vast domestic consumption is critical. It establishes the economic baseline required to finance the more complex, export-driven pillars of the strategy. Once baseload demand is secured, the strategy targets advanced manufacturing. The second pillar takes raw ethane, methane, and propane and synthesizes them into high-value petrochemicals, the exact materials required to manufacture agricultural fertilizers, medical supplies, and personal protective equipment. Over the last decade, Canada captured roughly $20 billion in petrochemical investment. The United States, operating in the same broader market environment, secured $250 billion. To close that investment gap, the government introduced the Alberta Petrochemicals Incentive Program, a direct policy lever designed to attract global capital to domestic construction sites. Capturing this market share provides a $30 billion growth opportunity, supporting more than 90,000 direct and indirect jobs by 2030. By running the molecules through a domestic petrochemical process, the province upgrades a low-margin raw gas into high-margin, globally essential products. Those manufactured plastics also require a managed end-of-life strategy. The third pillar establishes Western North America's Center of Excellence for Plastics Diversion. Currently, 86% of plastics end up in landfills. That represents $7.8 billion in lost material value across the economy. Recovering this value requires a technological shift. Instead of basic mechanical sorting, the province is advancing chemical recycling, breaking waste down to its molecular base. By chemically dissolving finished plastics back into raw polymers, the material is continuously fed back into the manufacturing loop to create new products. Achieving a 90% recycling rate by 2030 would scale the industry's domestic revenue from $500 million up to $3 billion. A functioning circular economy utilizes discarded plastic as a perpetual, high-value domestic feedstock. For the resources that are exported, the destination has to change. The fourth pillar focuses entirely on global egress, targeting the completion of 2 to 3 additional mega liquefied natural gas projects by 2030. This map highlights Canada's distinct structural advantage. Oceanic shipping routes to markets in Asia and Europe are significantly shorter from Canadian coastlines than they are from the U.S. Gulf Coast. A production capacity of 56 million tons per year would add an estimated $11 billion annually to the national gross domestic product. Building infrastructure on this scale requires active, meaningful investment partnerships with Indigenous communities connected to the project sites. Oceanic LNG provides the high-volume escape hatch. It completely bypasses the geographic trap, ensuring Alberta's natural gas can access premium pricing in international markets. The final step in this integration process addresses the strictest environmental constraints. The fifth pillar is the blue hydrogen economy, paired directly with carbon capture, utilization, and storage. This relies on large-scale natural gas reforming. Facilities strip the clean-burning hydrogen away from the natural gas molecule and capture the resulting carbon dioxide byproduct before it reaches the atmosphere. Alberta possesses a unique geological advantage, providing the massive subterranean capacity required to permanently sequester that captured carbon. The global demand for clean hydrogen is accelerating rapidly, with the market projected to reach $2.5 trillion by 2050. Domestically, that hydrogen is deployed into hard-to-decarbonize sectors, serving as a zero-emission fuel for heavy transport fleets and residential heating systems. For the international market, the hydrogen can be synthesized into methanol or ammonia, allowing it to be exported using existing pipeline and shipping corridors. By linking gas production to carbon capture, blue hydrogen ensures that Alberta's reserves remain highly relevant and competitive in a strictly decarbonized global economy. Operating these 5 pillars in sequence routes a single unit of extracted gas through a highly integrated multi-pathway value chain. Executing this sequence spans a 20-year timeline, moving from immediate regulatory alignment in the short term to full-scale commercial deployment and global export by 2040. This outcome relies on the rigorous application of advanced chemical engineering and highly coordinated intergovernmental partnerships. By engineering this integrated matrix, Alberta secures its future as a premier node for clean, secure, and low-emission global energy.